ready for it.
Okay, super, thank you. So I'm Mary Monahan. I'm with Fuss & O'Neill. That's Kurt Mailman. He's also with Fuss & O'Neill. And we're here tonight to continue a conversation that began in August of 2017 to talk about small sewers and potential funding opportunities. So before we go into the conversation, I wanted to just give a little bit of background as to who Fuss & O'Neill is and who we are, because many of you weren't here back in August of 2017. So Fuss & O'Neill is a consulting firm with 350 plus professional staff, engineers, scientists, planners. We have an office in Springfield. Our market is mostly municipal, roads, bridges, water, wastewater, planning. And that being said, I'm not an engineer. I'm actually, I come from the municipal side of things. I'm a former town administrator, public works director, elected clerk treasurer. So I've been in consulting for almost 20 years. And what I do is I add to the discussion between the local boards of selectmen and the municipality to help engineers understand how local projects need to fit in with that fiscal, political, and schedule that municipalities have. So I'll have a couple of things to talk to you about after Kurt gives his introduction and a brief presentation about wastewater that deal with the funding of anything you want to do moving forward.
Okay. Good. I was going to say, before Kurt talks, you want to give him the microphone?
I'm going to.
Okay. And Kurt, could you move that?
Yes.
Because I get a feeling Rini down there can't see much. There you go.
That's better, thanks.
Is this better?
Yep.
All right. How's this? Push the button. How's that?
Is that on, Ryan? Yeah, he says
Okay.
on.
Here.
Okay, he's one
Okay.
that has to hear it, I guess.
Perfect. Okay, so I'll try to stand over here so I don't block everyone's view. As Mary said, my name is Kurt Mailman, and I am a dirty water guy. I've been in wastewater for the last 30 years, believe it or not. And so I've got a lot of experience working with small communities like yours. I'm actually, if you're familiar with the New England Water Environment Association, I'm the chair of the Small Communities Committee, and our role as a committee is to help small communities that have less than 1 million gallons a day of wastewater flow. So we do a lot with small communities, a lot with small flows. And what we thought we could do today is talk about a little bit about your situation here in Southampton and maybe give you some ideas and things to follow up on and carry on the discussion and the dialogue and further it to help you with your wastewater needs. Okay, so bringing you back probably almost 2 years now, we came with a similar set of drawings. Charlie over here probably remembers that discussion. And there's really there are two primary areas of concern, although there might be others that you might identify for wastewater dispersal needs. And so this drawing shows you the Pequot Pond area, which is half sewered into Westfield. I'm sure you've seen similar before. The purple areas here are Zone 2 aquifer protection areas, and the red is the existing infrastructure that exists, including a pump station on Long Pond Road. And that pump station was actually sized to accommodate flow from Southampton when it was designed. So there's a piece of infrastructure that's already in place along the Pequot Pond. So what are the things of concern associated with that area? Well, it's very densely populated. There are about, I want to say about 400 properties there. And the soils actually are pretty decent. They're well-draining soils. Unfortunately, they're draining nutrients into the Pequot Pond. So there are issues with water quality as a result. And so, that's the primary reason why the lower section of Pequot Pond was sewered in Westfield many years ago. So people may not notice that there's a wastewater issue because the effluent is actually traveling quickly through the soils, so it's very rapid. This second drawing here just shows, again, here's, to orient you, here's where the pump station exists, and there's a little bit of collection system over here as well.
How many of those 400 or so homes are actually hooked up to the Westfield sewer system there?
There are 400 in Southampton.
Oh, so 400 are all in sewer, okay. Oh.
Those aren't on sewer, those are the ones that should be, those are in the sewer.
Correct.
Right, those are
Right.
not.
There
Right,
there
okay.
aren't any on the northern side.
Before I go on, now I'm confused. Are there Southampton homes hooked up to the Westfield?
No.
No.
Okay, none,
No.
okay.
All the infrastructure ends at the line.
Okay.
And so there's
I should have showed you
400
where
so
the
there's
line was.
400
So-
homes
so
in
with-
Southampton that are not connected, that are presumably polluting, really?
There have been studies that have indicated that there's nutrient issues there, going back to, I believe, 1987.
Okay.
So,
And so
it's
that's
not a
hard.
new issue, but there hasn't been, historically, there hasn't been action to work with that.
So that existing pumping station is servicing Westfield?
Yes. But previous studies showed that there was 50,000 gallons a day capacity built into that pump station to handle Southampton's flow if and when they ever wanted to tie in.
And that's
But just for
capacity
that
still
area?
there?
What's that?
Sorry, go ahead.
Just for that area, though?
Yes,
Yeah,
that's
just
right.
for the Pequot area.
That's right.
And that capacity is still there as far as you know?
Yes,
Okay.
And what does that represent in terms of homes?
that would
The 400?
theoretically handle the northern section of Pequot Pond. Okay.
I just wanna- Well, let them do the presentation, yeah.
So the other area that we spoke about a couple of years ago was the Route 10 corridor, okay? So here's your line between Southampton and Westfield. And this area is currently not served by any public sewers. There are, as I showed you before, there are some sewers in Westfield just over the line. And there were some studies that were done that previously that recommended sewering the entire town of Southampton by various means, some connections to Westfield by public sewer and some more decentralized community type sewers and systems. So one of the recommended areas was a groundwater discharge off of the Manhattan Meadow, just to the west of the Manhattan Meadow. And what I'm going to talk about in a couple of minutes is some newer technologies that make that a little bit more attractive and maybe a little bit more cost effective than previous recommended plans. There's also an opportunity potentially to route some of the areas with issues with septic issues and decentralized wastewater issues to Easthampton. So back and forth through the years, there have been discussions to connect to Easthampton or not, depending on their capacity. So those are things that you can also consider. Westfield presumably has enough capacity to handle wastewater and process it at their wastewater treatment plant. Easthampton reportedly also has some capacity available. And I've worked with a number of communities to formulate agreements, intermunicipal agreements, to make those a reality, so that they're very, it's important to craft those in such a way that it protects the community. I've got a lot of experience doing that. So this Route 10 corridor here, the idea was generally to foster economic growth along that corridor rather than to abate pollution problems. And so there may be some areas, you've got wide open spaces along this corridor, so in theory you should be able to find that 4 feet of separation to groundwater because you got large parcels and you can pick and choose. So the focus from the Pequot area is more water quality. This is more of an economic development focus. And it could also process You could also process flows from the northern section of Route 10, either to Easthampton or down to what we call a community system. This is just showing the directional arrows of where the wastewater theoretically would come from. This is just a quick graphic that corresponds to why there's a potential pollution problem by surface water areas like the Pequot Brook. You have to get that separation to groundwater, and in a lot of instances you can't have that unless you mound systems, but they're very expensive to do on a parcel by parcel basis. So what ends up happening is there's a possibility that you hit the groundwater regime because the soils are so permeable and the pollutants travel quickly out into the surface water bodies. So I've talked a little bit about concerns and issues and locations. I'm going to talk now a little bit about technologies to assist. And there are some newer technologies that are available that probably weren't when the original sewers were constructed in Westfield. And one of them is low pressure sewers. And I'm not sure if anybody here is familiar with them, but essentially the old way of doing a sewer system, particularly with a lot of topographical change, would be to collect your pipes in your gravity sewer and have a series of pump stations to pump up over the hills. Okay, but what that does is it requires depth when you get to high points in the area. You have a deep excavation, which is very costly, particularly if you're in groundwater. So the newer style is really to implement individual miniature, what they call grinder pumps on each property. And what that allows you to do is only dig 4.5 feet instead of dig as deep as you need to get connected by gravity. So there's a cost savings. On the other side of the ledger, each individual house has a small grinder pump sited to process their flows. So, people would ask questions about, well, what about power supply and redundancy, things like that. So these grinder pump systems are built with connectors so that they can, you could put a portable generator out. You can essentially make them almost idiot-proof.
So it's almost like a sump pump that grinds, then pushes it up?
Yes.
Okay.
Yes. And the systems are sized with telescoping sized pipes based on the number of pumps that are in the line. So the first 3 pumps would have a small size, and then the sizes would get larger as you went through the system. But the real benefit is if you're on bedrock, it reduces that, and it also helps you with water control during construction. Here's a cutaway of what that pump would look like. Okay, it's got a rotor and a stator and a grinder mechanism, and they're very reliable. Not only that, they don't use much electricity. It's like the equivalent of like a 40-watt light bulb.
So does that go, when you flush a toilet or whatever, does that automatically put the pump on? Or is there a reservoir that it collects for a while, then it pumps it out?
Yeah, there's a small holding tank in each one of these. Usually it will range between 20 and 40 gallons. If you had a commercial building, they would sometimes double those up or make a wider base to it with a larger collection area so that you could store more wastewater before it pumps.
So it saves energy and
Yes.
wear and tear?
Yep. So I wanted to talk a little bit about some of the technology available for community systems. Okay, so what I've got here is a thumbnail graphic of what the 1990s, early 2000s small treatment system would entail. So you've got some clarifiers, circular clarifiers, and you've got some aeration tanks, and you've got sludge, and it's a pretty large footprint. And generally the engineering design standards would allow you to have additional footprint to add additional tankage or clarifiers, things like that. So I was just showing this graphic to show you the that the new systems, of which the membrane bioreactor, which I show over here on the left, they're much more compact. They actually essentially come on flatbed trucks, and they're modular. So you can stack them one after the other, taking up a smaller footprint and really allowing you to make the capital expenditure in parts or in pieces rather than a huge capital expenditure all at once. Some communities under this style would overbuild their wastewater treatment plants. They wouldn't have enough flow. Then they wouldn't have enough microorganisms to process the wastewater, and it would cause upsets and poor treatability. These modular systems produce a very high quality effluent, almost drinkable effluent that you can disperse.
Almost.
Almost. The newest thing on the horizon, the real cutting edge view of these, particularly when you have a really high quality effluent, is to implement what they call smart sewers. And smart sewers actually act as a resource recovery tool where you would theoretically, if you had buyers, sell the water for irrigation and sell the sludge that comes out of the tanks annually or quarterly, and actually turn that into a revenue stream for the facility. So, you know, that's where we're heading as an industry, and probably in my lifetime we're going to see it expand. It's in the Northeast, it's a little less accepted right now because we tend to be a lot more conservative in the Northeast, but it's going to happen. So just a couple of pictures down below. You can see this is a treatment system. This is an MBR system. It looks pretty ugly, but it's just dropped off modular flatbed. And this is another system here. This one is in Littleton and processes 40,000 gallons a day. Pretty small footprint. That's the treatment piece. You still have to disperse it. You still need to get it in the ground. So you need some kind of system to, to disperse your effluent. Here's another example. This is a different type. This is called an amphidrome. Again, a lot of this is buried. All you would see is this small control building. You've got an anoxic tank for conversion of the nutrients. And you've got a bioreactor here, clear well reactor, and your pumps out to your dispersal system. So what it does is it intermittently, with blowers, adds oxygen and then takes it away. That's the way you nitrify and denitrify, which removes the nitrogen pollutant. So once you've got your clean effluent out of one of these systems, then you need to do the dispersal. And very new in the industry and becoming ever more accepted is drip dispersal. And what drip dispersal does is it discharges through small tubes, small 5/8 inch diameter tubes that have little perforations and emitters. And they allow you to actually plow in, for those of you who are familiar with farming, you actually use a little plow, and you don't have to dig a huge bed the size of this building anymore. You can actually plow these little tubes in, and each little emitter discharges a known amount of flow every pump cycle. So what are the benefits? It's easy to construct, very shallow bury, so you don't have to, if there's places with bedrock and high groundwater, helps you get that separation because now you're in the upper soil horizon, and it becomes more cost effective to install. So that's something that's fairly new on the horizon. One of the gentlemen from Oakson is one of the manufacturers, and he actually was on the Small Communities Committee out of Gloucester, Mass, and he's been one of the champions of that technology. There are really two manufacturers that do that type of drip dispersal, but it's ever more common in the Commonwealth. Here's another, I forgot to mention, I'm also a member of NAURA, which is the the National On-Site Wastewater Renovation Association. So we go on field trips and look at who's doing what all around the country in terms of decentralized wastewater. Here's a different style. These are called pressure distribution nodes, and these are essentially infiltrator chambers with pressure dosing. Again, this would be not in the same soil horizon as the drip dispersal. It would be a little bit lower, but still pretty high in keeping that 4-foot separation. And these would have pumped cycles at a certain interval to evacuate all the wastewater that was generated from your treatment system. And that's pretty much the thumbnail sketch of a few issues and some potential solutions.
So the effluent that's going out the tubes are in here. I mean, if you're doing this for years and years and years, do you have to replace it or move them, or?
That's a good question. So typically, all of these things are sized appropriate for a certain dispersal over a certain area, okay? Certain gallons per day per square foot in technical terms. The power of having a high quality wastewater treatment system up front, it's almost like putting water into the ground. So because there's not a lot of bacteriological growth, it's not like a septic field at that point because it's almost clean water. So there's not a lot of biomass or biomat that forms in these systems. So if they're sized with the right gradation, you do have to do some soils analysis to make sure you've got proper permeability of the soil. But once they're established, if they have a packaged system up front, they will last a very, very long time.
So it sounds like Hamden Ponds, there's some potential from Westfield. There's maybe some tie-in from Easthampton and Westfield. I know this was all looked at before, and I'm sure, Charlie, you're going to have some information. Or we can build mini plants ourselves.
Right. Community plants.
So you're here presenting this. I guess the obvious question is, what can you do? What do you recommend? Because we're pretty new at this, and I think we all would agree that if we can get some sewer system in here, even if it's partial, it'd be a big step in where we're going.
Well, what we like to do is integrate in with the overall townwide planning, and generally comprehensive wastewater management plan does that as part of its, as part of its protocol, as part of the deliverable. Massachusetts is very stringent on their programs and what they accept and what they don't. So usually it's a stepped process where the boards and commissions and the wastewater folks come together and formulate what the town-wide needs are through that comprehensive wastewater management plan. I think the last one that was done was maybe 97-ish, so it might be a good time to take another look at that.
22 years ago.
Okay.
So, you want me to add to that?
Sure.
So,
Do you need this?
I've got one here. So what Kurt talked about is great, because there are all these options depending on why you need to do it or why you want to do it, whether it's water quality, whether it's economic drivers. And all of those options bring with them additional funding opportunities to help get you started. So Kurt noted the CWMP, the Comprehensive Wastewater Management Plan, and as he said, Mass DEP, which manages a lot of the funding that would be available for your project, would require an update to your CWMP in order to give you monies to keep moving forward. And that update to the CWMP would do exactly what Kurt was just talking about. It would look at what do you want to do, why do you want to do it, where does it need to be put, and requires the community to be part of it. It's not only looking at the hard infrastructure that you might want to put into the ground, but it takes into consideration input from the town, because the town at some point is going to be paying for this. It looks at how are you going to pay for this. There's multiple ways, whether it's user fees, whether it's betterments on the properties that are being bettered as a result of having access to sewers, whether it's a combination of those plus taxes. All that is part of that discussion. How much will it cost? How do we pay for it? And it also looks at your environmental impacts. The DEP doesn't want you to do anything that's going to make situations worse. So as Kurt noted, it's a very prescriptive process. So we would go back to looking at what you have done. It would be updated based on new technologies, new priorities from the community, and in particular what Mass DEP thinks is important, because at some level they actually hold the purse strings. So the state revolving fund, which is a loan program, that can be a source of funding for this. It's also a future source of funding for any construction phase. It's a 0 to low interest loan that can be extended up to 30 years. Most traditional borrowings are only 20 years. That would let you go a little bit longer. The U.S. Department of Agriculture, USDA, that's another potential funding source, and depending on income levels in the communities being serviced, that could be a combination grant loan or a loan only.
And they're flush with money right now.
Pardon?
They're flush with money right now. The USDA-RD is looking for projects to fund.
And they have projects that actually fit into some of the study phases. So the other opportunities out there, especially along the Route 10, is MassWorks. And that's a state grant that looks at infrastructure needs associated with economic development, particularly job
We
creation.
just received one for the bridge.
Okay, so that's an annual opportunity to go after funding. I don't know how old the bridge one was, and you must have had an economic development tie-in to it, because it's really focused now on making sure that there's a private party, a private initiative associated with it. For example, a business that would locate here and bring these jobs if they had access to wastewater treatment, or a business that might think they have to leave because they don't have access to business. So MassWorks is out there. There's an application due in August. I don't think you have time to put together the kind of quality application, but think about next August. The other opportunity out there is EEA just closed on a planning grant to do studies. It was up to $50,000, and one of the eligible projects included looking at village center wastewater management. So with the right words being used in an application, you could deem many of these sites as village center or, economically development driven to look at what might the wastewater needs be, because Kurt and the engineers can't pick a solution without that kind of study. It's not like, let's just go do this tomorrow. And then the other major... That just closed? That just closed in May. And the other opportunity, but that's an annual. So the other one that I really like talking about, because it's almost, I shouldn't say this on TV, but it's also like write your own grant, is the Municipal Vulnerability Preparedness Program.
We talked about that.
Okay, so I've worked with almost 30 communities now in doing an MVP, and we recently, our communities, 8 of them got $2.5 million to do some of their infrastructure work that came out of this MVP planning process. So you definitely want to stay alert. I can let you know when the next MVP planning grant hits the streets, so that you can go through the planning process, which is funded by a grant.
They just had a deadline, but I was told that there was another summer cycle.
There's supposed to be. EEA has said that there's going to be another cycle in summertime. They've had 3 on the planning side, and they've had 2 on the action grants. So the action grants are where the big dollars are. The action grants are where you can go after the funding to dig down a little bit deeper into the planning and the study of what do we want to do here. And then what we've learned with these 2 rounds of action grants is after you do those studies, again, there's always got to be a climate change discussion associated with it, whether it's flooding that would affect soils, that would affect, treatment options. Once you do that initial study, EEA was true to their word, and they funded now the construction projects that came out of that. So that's what we got for communities the second round. So you need to get through the planning first to become a certified MVP community, and then you're eligible for applying for the action grant rounds. And right now, the governor and the legislature are pretty comfortable discussing that over the next 10 years, they plan to have $10 million available to support these types of projects.
Per year or total?
Per year. Yeah. The governor's office and the legislature are putting a lot of monies into climate change resiliency. And another component of it, I heard another previous discussion, is energy efficiency, greenhouse gas reduction emissions, and all that. And that's,
Emergency management.
yeah, and that's all part of it, and there's a new Greenworks bill that's out there too that's going to complement and add to these opportunities. But you almost need to know where do you want to go with that. So that's why these initial studies become very important. You need to have a plan. You need to the community needs to have thought it out and looked at the technological opportunities as well as the limitations.
Questions? A lot to think about for sure. I think there's some opportunity that we need to pursue. Questions, though?
No, it's very interesting, thank you.
We have your contact information?
I do. Do you want to leave the boards behind?
Sure.
We did that the last time too. We'll leave the boards if you...
I can't put this board
Okay.
Oh, okay, sorry.
I've got your contact info.
Thank you very much.
Thanks, Mary. Thanks, Mary.
Thank you.
They were on.
So you're